Wow. Wow, wow, wow. Thank you ever so much. Has anybody here heard of my stuff? If you can just, some of you, right? Who is this completely new to and you have no idea what I'm going to be talking about? The vast majority. Excellent. Right, X marks the spot. I'm going to start with the origin of how I got into mapping. Then I'm going to talk about maps themselves. What is a map? I'm going to talk about how to map, why we should bother. Then I'm going to talk about patterns. And after we talk about patterns, I'm going to get into the concept of change. So how we use maps to understand what's going on with our industry, our space. And then I'm going to get into gameplay. And finally, I'm going to wrap it all up in X marks the spot. And I'm going to try and do this with a ridiculous number of slides. If we actually get this far, then I'm going to talk about AI, particularly some of the horror stories. And then finally, I'll get into something called digital sovereignty, if we get that far. Does that make sense to everybody? Yes. Right, super. So let's start with the origin. So many years ago, I was working for this company. It was an online photo service. This was back in 2004. Very profitable, 16 different lines of business, but it had a massive problem. And the problem was this person, the CEO of the company. Our fat cat was completely clueless. They had no idea what they were doing. They were making things up as they went along. Now, I know this for a fact because I was the CEO. I used to come up with these wonderful statements. You know, our strategy is customer focused. We will lead an innovative effort in the market through our use of agile techniques and open source. Wonderful stuff. I'd literally pinched that from another company and just changed a few words. That was the level of strategic play that I was exhibiting. And I used to read every book I could find on strategy. I was getting nowhere. And I ended up in a bookshop in Charing Cross in London. And I was talking to the bookseller, and she said, "Have you ever read Sun Tzu's The Art of War?" And I went, "No." And being a good bookseller, she sold me 2 different versions of the book, because they're all translations. And I'm really, really grateful for this, because it was in reading the second version, I noticed a particular pattern. So Sun Tzu talked about 5 factors that mattered in competition. First, have a purpose, a moral imperative. Second, understand the landscape that you're actually competing in. Third, understand the heavens, the climate, the weather, how the landscape is changing. Then you get into principles of organization, or the collection of principles we call doctrine. And finally, you get into gameplay. How do you manipulate the space to your favor? Now, I was fascinated by this. And at this time, I also came across the work of the mad major, John Boyd. Anybody heard of John Boyd? Famous for OODA loops. So very heavily used in political circles as well, through a particular process called the cycle of outrage. John Boyd was a major in the US Air Force, came up with this concept of OODA. So the first O of OODA is to observe the environment. That's what landscape and climatic patterns are about, observing the space you're operating in. Then you orientate yourself around the space. That's what doctrine and principles are about. And then you need to decide where you're going to act, and then you act. So that's the OODA, observe, orient, decide, act. And they overlap quite nicely together. And so I had this strategy cycle. Now, for me, this sort of made a lot more sense than anything I'd been reading beforehand. And I started to ponder this question of how do I observe the landscape I'm competing in? And that's what got me into maps. Does that make sense? Good. So I started to read everything I could find on military history, because they use maps a lot. And One of my favorite battles is this battle, the Battle of Thermopylae. So Themistocles was an ancient politician, Greek general, had a problem. The Persians were invading. Now, there are about 140 to 170,000 Persians. We don't quite know how many. And of course, the Greeks were independent city-states which worked together when there was an invading force. And so what Themistocles decided to do was to block off the Straits of Artemisium, force the Persians along a narrow pass called Thermopylae, or literally it means the hot gates, where a small number of troops could defend against a larger force. Now, there were 4,000 Greeks against the 140, 170,000 Persians, and including in that 4,000 were 300 Spartans. And that's where we get the story of the 300 from. I was fascinated by this. I could see the maps, how you could use it to coordinate. So I started to think about my business. How was I operating? Well, I was using something called a SWOT diagram. Have you ever heard of SWOT diagrams? So I created a SWOT for this battle. Strengths, a well-trained Spartan army, a high level of motivation not to become a Persian slave. Weaknesses, the E4s might stop the Spartans turning up. A truckload of Persians are actually turning up. Opportunities, get rid of the Persians. Get rid of the Spartans. We're Athenian. We actually hate the Spartans, so if we can get rid of them, that's a bonus. And the threats, the Persians get rid of us, and the Oracle says a really dodgy film might be produced in a few thousand years later. And so I simply put this next to each other and asked, what would you use to communicate and determine strategy in battle? A SWOT diagram or position and movement on a map? So what would you use? A map. What was I using? Magic framework, yes. So I went back to my office and said, right, everybody, give me all your maps. And I got loads of maps. I got mind maps, I got business process maps, I got systems maps. This is one of the systems map. Various components connected together. And I was looking at this map and I thought, well, I'm going to take a component, CRM, and I'm going to move it across the screen. Isn't that exciting? Right, now I'm going to ask the question, how has the map changed? How has the map changed? Any answers? It hasn't. But if I take a geographical map and I shift Australia and put it next to the UK, that definitely has changed. So why hasn't it changed here? Any ideas? It's not a map, exactly. The one thing that all the maps that I had in common was none of them were actually maps. They're all graphs. So to explain the difference, here's 3 locations in the UK, Nottingham, London, Dover, connected roughly by 2 roads, the M1, M2. Now, if I move Dover like that, has that changed? No, it's just a graph. In fact, all these 3 diagrams at the top are all graphs and they're identical. But the 3 diagrams at the bottom are all completely different. And they're all maps. So why are they different? Okay. The difference between a map and a graph is in a map, the space has meaning. It represents a landscape. It's not nothing, the white space. It's actually a landscape. Now, in order to give space meaning, you need a number of components. You need one, an anchor, such as magnetic north. You need position of pieces, and you need consistency of movement through that landscape. So how do you map a business? Any ideas? I hadn't got a clue. All I knew is I didn't have maps. So I found a way. It took me approximately 10 months, 9,223 publications later, to find a way of doing it, and a lot of accidents. I'll explain it through a cup of tea, because I'm a Brit and I like cups of tea. So I want you to imagine I run a tea shop. What's my anchor going to be on a tea shop? Well, I might have the public who hopefully wants to consume my cups of tea, and I have the business who wants to sell cups of tea. So those are my anchors. I could have regulators who want to make sure that my tea isn't poisoning people, something along those lines. That's fine. So I've got an anchor. Now what? Well, it turns out that a cup of tea has needs. It needs a cup, it needs tea, it needs hot water needs cold water, it needs a kettle needs power. So what I've got is a chain of needs, and that gives me position. The further I go down the chain, the less visible something is higher up that chain. So that's anchor and position. But what about movement? Well, this was the hard bit. Because how do you describe movement in a space like this? Well, it turns out that there is a landscape, and that landscape is capital. So capital as in terms of the activities, practices, data, knowledge, even the values that we have. And that capital is evolving through common stages. Now, we call them stage 1, 2, 3, and 4, but that's really meaningless. So what I do is I use labels for each of those stages. And the labels I commonly use are these: geneticist, custom-built, product, commodity. So I simply take my chain, my graph, and I ask how evolved are these components? Is it a commodity? Is it a product? Is it custom-built? Is it something totally novel and new? Now, this is a map. So what? Well, the point about a map is I'm actually putting my story into a form that you can easily challenge. You might ask, why have I got kettle and custom built? You might say, I'm missing staff. Normally in organizations, we use stories. Now, we tell everybody that great leaders are great storytellers, and that creates a problem. Because when you challenge somebody's story, you're challenging their leadership ability. So they get very, very defensive. If you can get them to put it in a map, I can say, I think there's something wrong with the map, not the person. Does that make sense? Good. So here's a typical example. This is from an insurance company. This is 2010. I've been mapping for almost 20 years now, so this is all quite old, and this is all Creative Commons. This is about 2010, 2011. They had a problem. They needed compute, order server goes into goods in, they mount, modify, rack it. There was a bottleneck, and they wanted to improve the process flow. So they came up with this idea of investing in robotics to get rid of this bottleneck. It was a multi-million-dollar capital investment. They had built the entire business case, return on investment calculation, sub 1 year. They're about to go. And I was asked, could I have a look at it? Now, the problem is I can't go in and challenge their story because they built this whole story. So I said, well, could we map it? And they went, oh, we don't know about that. We don't. 15 minutes of arguing. Then we said, all right, we'd map it. It took 15 minutes to create the map. Here's the map. It was 2010. Right, user needs compute. Compute order server, very commodity-like. Server, commodity-like. Interesting, server's commodity, but compute they thought was more late product. Okay, goods in, rack mount, modify. Anybody got a question to ask about that map? Perfect. Why are the racks in custom built? That's all I did. I said, why have you put racks in custom built? And they said, we had custom built racks. What are the modifications you're making to servers? Well, the servers we buy don't fit our racks, so we have to take cases off, drill new holes, add new plates in order to get them to fit our racks. And that's why you need robotics, yes. Do you know what happened about 2 minutes later, what somebody said in the room? Why don't we use standard racks? Now, remember, these people weren't daft. These people had spent 6 months working on this problem. The issue is they were trapped by past stories. At some point in the past, there was no such thing as a standard rack. And so being very sensible, they thought we'd organize their compute, and they had custom-built racks. No one had challenged that story. In fact, what they'd done is they spent all their time improving process flow. And if you improve process flow, you would invest in robotics, because it makes sense, and the return on investment calculation is sub 1 year. They never considered evolutionary flow, that the things actually change. Does that make sense? How many of you have seen this problem before? Okay, that's more than map. That's pretty impressive. All right, so one of the things I do with maps is what I call pre-mortem, post-mortem. So before I do something, we map the space and we use it to challenge, to get rid of all the common problems. And then we go and, once we've got a map, we go build it. And once we've built it, we come back and we look at the map we created and do post-mortem learning. And from that, we learn patterns. So I'll give you an example of a pattern. This is HS2, high-speed rail, big heavy engineering project, UK. This is James Finley. James Finley was the CIO for HS2, had a problem. We needed to build the entire railway in a virtual world because it's cheaper to dig up a virtual world and go, whoops, we've got that wrong, than the English countryside. It's a sensible thing to do. This is the systems graph for building HS2 in a virtual world. Any suggestions on how to manage that? How would you manage it? Don't say safe. Sorry. I was the chaos monkey for the Safe Leadership Summit back in 2019. I tore into them, but it doesn't matter. That's another story. How would you manage? Any ideas? I'll tell you, back in 2011, 2012, I think this was about 2012, we used to outsource a lot in government. So we'd break it down into common components, so bounded context would say like power, data center, compute, that sort of infrastructure. We'll put it in one project. We'd go, GIS, land registry, that's all engineering. We'd have another contract and we'd outsource it all. So multiple different contracts we'd outsource, and then we'd have mass cost overruns and failures. Anybody experience that? Yes. So James spent Sunday afternoon, mapped it out, sent me the map. This is what the map looked like. It was 2012, and said, how do you manage something like this? This was easy for me. See, back in 2005, 2004, back in 2000, it was a friend of mine's, Ken Beck, I'd adopted extreme programming throughout the entire organization. By about 2004, we realized it didn't work everywhere. And once we couldn't explain why, once we had maps, we had a way of explaining what the problem was. So it was easy for me to explain to him this pattern that I'd learned beforehand. So here's your map, and all the components are evolving from the uncharted space on the left-hand side to the more industrialized space on the right-hand side. It doesn't matter whether it's money, computing, penicillin, all starts over here on the left. So compute, first compute Z3 in 1943, then you get custom-built examples like Leo, then you get the products, first products IBM 650, rental services like TimShare, commodity hardware and cloud eventually. So everything's evolving, and what we'd learnt is there's no such thing as one-size-fits-all project management methods, or purchasing methods, or finance methods. So on the left-hand side, you're all about change. So what you want to do is reduce the cost of change. So extreme programming, very good on the left. The same thing as it evolves over an unspecified amount of time, ends over here in the more industrialized space. Well, there you're reducing deviation. You don't want change, you just want the same thing, but many, many times. So Six Sigma outsourcing works well. And in the middle, you're all about learning and reducing waste. So things like lean works well. So we simply apply that. You do stuff on the left, build in-house agile techniques, stuff in the middle, off-the-shelf products. If we're going to have to build, we'll go down lean. Stuff on the right-hand side, outsource to utility providers if they are provided. If they're not, if we're going to build our own utility service, we'll be doing something like Six Sigma. Does that make sense? Easy, isn't it? Use appropriate methods. There's a world of difference between being agile, or using agile, I should say, so using things like extreme programming, and being agile, which is using appropriate methods, including maybe waterfall over here, a lot of off-the-shelf products in the middle. Of course, if you turn up to an agile conference and say agile doesn't work everywhere, they will go, burn him heretic. It's okay, you can go to a Six Sigma conference and say, which I've done, Six Sigma doesn't work everywhere, and you get burn him heretic as well. So let's take one of the original contract structures. There we are from the graph. I'll simply overlay that on a map. That's what that contract structure would look like. I know that this contract will fail as soon as we've signed the paperwork. Why? Because the stuff on the right can be specified. So we can put it in a contract and know what's going to be delivered. The stuff on the left can't be specified. It's always going to incur massive change control cost overruns. Now, unfortunately, if we go back, the worst thing that can happen to you is you get into a fight with the vendor says, oh, but we delivered all this stuff and blah, 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 and you say, yeah, but at massive cost. Well, that's because you didn't know what you wanted. You can't know what you want. The problem is the contract. The worst thing that happens is somebody on your own side turns around and says, next time we need to specify it better. No. No, go safe. My only suggestion there is fire them. So anyway, it always leads to cost overruns. Now, to give you an idea of scale, one project alone in UK government, we save 450 million simply by changing the contract structures. This stuff has been used all over the place. I mean, my friends at Planet Labs worked with NASA on putting the Carbon Mapper satellite. They actually used maps between the two different groups. I didn't even realize NASA was using mapping. I found out yesterday. Today, somebody mentioned they were. But anyway, I want to give a quick test. This is the Elvish self-driving car. So what I mean by that is I've taken a self-driving car and translated the system diagram into Elvish. And I translate it into Elvish because, well, to IT, finance is a bit Elvish, and finance, IT is a bit Elvish. So I'm going to be IT, and you're going to be finance. Here's the systems diagram. I want to cooperate. I want to collaborate. I want to work together with you. So A, B, and C. A, what should we do with it? Do you think we should outsource it, build it in-house, or maybe use off-the-shelf products? What do you think? Any suggestions? Anybody willing to say? Build our own. Okay. People actually make these decisions based upon this sort of information. You shouldn't do anything, actually. All right. So let me try it again. Exactly the same, but this time mapping format. A, should we outsource, build our own, or off-the-shelf products? What do you think? Outsource it. C, what should we do with C? Off the shelf. What about B? Easy. Make sense? Yeah, you might disagree and challenge. We can put the proper words in there, but at least now we're thinking about using different methods. Right. There are three basic types of patterns that you see in mapping. Climate, doctrine, and leadership. So climate are the rules of the game, and there's about 30 of those, and they're useful for anticipation. Doctrine, there's about 40 of those. These are universally useful principles, things like focus on user needs, understand the components, understand how evolved the components are. And then there's gameplay. There's about 150 of those. And we have no chance of going through most of this stuff, so I'll mention a little bit about changes. So this is roughly a map of compute in 2005. User needs an application built on best coding practice, on a runtime operating system, all the way down to compute. Computer's a product. The first pattern you learn with mapping in terms of climatic pattern is everything evolves. If there's supply and demand competition, stuff will evolve. So back in 2005, we knew compute was going to become a utility. I thought it was going to be Google. Turned out it was Amazon 2006. It was actually a friend of mine, Ben Black, who proposed EC2 to Jeff Bezos in 2003, built by Chris Pinkham and others in South Africa, because Jesse Robbins, who ran Amazon's data centers, wouldn't allow this EC2 nonsense anywhere near their data centers. Anybody telling you a story they were selling spare capacities, just complete garbage. Standalone service. That's the first pattern you learn. Everything evolves. Second one, past success breeds inertia. Blockbuster, Netflix. Who was first with a website? Blockbuster, right. Who was first with video ordering online? Blockbuster. Who was first with video streaming experiments? Blockbuster, fantastic. Right, who went bankrupt first? The problem with Blockbuster was not that it lacked innovation. It out-innovated everybody. The problem with Blockbuster is its business model was based upon late fees. Do you remember? Oh, some of you won't remember, but those of you who do, we used to get those cassettes and we'd say, yeah, we'll bring it back tomorrow. Then we forget and we got charged extra money. Remember that? That's most of their business model. You can't do that with streaming. Netflix was a DVD mail order company, didn't have the problem. All right. The next pattern you learn is coevolution of practice. So as compute became a utility, a key characteristic that changed was MTTR, mean time to recovery. So it used to take us weeks, if not months, to get a new machine. Anybody remember those days? It then took seconds. So our practices changed. So we used to do things like capacity planning, scale up, disaster recovery tests. Do you remember those? Change control. Oh, exciting stuff. And of course, then it became more of a utility, so we could then do distributed systems, design for failure, chaos engines, continuous deployment. We weren't waiting months for the machine to turn up. Now, Andy and Patrick eventually gave it a term. I mean, these practices were going on. Andy and Patrick came up with the term. I think it was infrastructure as code first, and then it was DevOps afterwards. That's pretty standard, though. Things evolve, you get a new practice. The next thing that happens is efficiency enables innovation. So as the underlying components become more commodity-like, it's much faster to build novel and new things on top, like Netflix. And then you learn the higher-order systems create new sources of value of worth. And if you're competing against others, and they get the benefits of efficiency because of a utility provision of compute, speed in terms of the practice, new sources of value, that creates pressure on you to change. And the more people who adapt in that space, the more the pressure mounts. That's known as the Red Queen effect. Professor Van Valen. Okay, so why does this matter? Well, you can use this to work out where to invest. So you've got the line of the map, you know things are evolving, so you know there's going to be a new emerging practice, so you can say, right, those are the spaces we want to invest in, this is where we don't want to invest, stuff stuck behind the inertia barriers. Have you heard of a company called Canonical? Provides something called Ubuntu. So I used to run strategy for Ubuntu, 2008. We were up against Microsoft and Red Hat. They had all the money, all the resources. We had a map, much more complex map than this one. And we used it to attack the space. $500,000 it cost me. It took me 18 months with the team. We went from 3% of the operating system market to 70% of all cloud computing. Was anybody involved in cloud in those days? Do you remember suddenly Ubuntu was everywhere? You were mapped. Oh, I love that. Oh, exciting. Right, anyway, eventually the emerging practice got a new name. We called it DevOps. The old best architectural practice for compute as a product got a new name. We called it Legacy. Then the runtime. Around about 2014, the runtime became more of a utility. We gave that a new name, serverless. Exactly the same patterns happened. Efficiency, a new set of practices appearing. Didn't know it was going to be called FinOps. Eventually got the name FinOps. New sources of value, etc. Why does that matter? Well, by 2016, where you wanted to invest is those space, and where not to invest. Oh, hang on, DevOps and cloud, don't invest there. No, it's heading towards the new legacy, because it was all focused on infrastructure. Yes, it's tried to reinvent itself as a more cultural system, fair enough. If you turned up at a conference in 2016 and said DevOps is the new legacy, how do you think people would respond? Burn him, heretic. All right, but the important point about this is that strategy is iterative. It's not fixed, it changes. There's no time on a map. What happens is maps change over time. So your strategy itself, which is why you should label maps with the date, but your strategy will change as the map changes. Now, there's a wonderful book all about serverless, The Flywheel Effect, Dave Anderson. It's all about an insurance company moving into this space. You'll find lots of mapping in there as well. Does that make sense to everybody? Good. Right, so that's roughly the map. I'll ignore most of it and stretch it out a little bit more. So what we've now got, user application, coding environment, FinOps, serverless at the bottom. One thing we noticed in 2018 was how cognitive computing, I don't like the term AI. AI is a massive, great big field, contains many different components, one of which is machine learning, which contains subsections such as large language models, large multimodal models. I'm just going to generalize this into the idea of computational cognition, a bit like human cognition, but more computer-based. We could see this was evolving, so we knew something was going to happen. We didn't know what. And we were like challenged, well, why does that matter? Well, the interesting bit is when you combine it with other practices to create a new set of practice. And we called this conversational programming environments. So this is based upon the idea of Nicholas Negroponte and Jonna Freeman. The process of design is a conversation between the minds of multiple designers. And basically what we suspected would change is one of the designers would become the machine. So Alexander Simovich, a friend of mine, using these concepts, then went and built this, took it to AWS reInvent in 2018. So this was an entire system built on AI, which you had conversations with, and it built other systems for you. And that was conversational programming. So roll forward a little bit longer, we knew where to invest. And when we get to 20, we now have terms for this. We call this large language models, large multimodal models. They're the more interesting form. And we now call this copilots rather than conversational programming. Same difference. Okay, gameplay. So one of the things you use maps for is by applying climatic patterns to see how things are going to change. You use that for investment. But once you've done that, can you manipulate the space to your favor? There's about 150 different ways of doing this, and we don't have time. But these are gameplays. They're all contextual. So you've worked out where to invest. How can I manipulate the space? One of my favorite ways is through the use of open source. If you want to drive something to more of a commodity, just simply open source it. Great way of doing it. There's others. You can create artificial constraints. There's all sorts of evil misinformation programs that you can use, finding weaknesses in other organizations. Another particular model, which you've probably come across but didn't know the name of, is ILC, Innovate, Leverage, Commoditize. So very simple. You take a pre-existing product, turn it into a utility. Let's give an example. Let's say compute. So we're going to take compute, we'll turn it into a utility, we'll give it a random name, we'll call it EC2. Now what you do is you expose it through an API. And what happens then, hopefully, is other people build on top. Now, their data is their data, you can't touch their data, but you have to bill them. And that billing data is your data. So you can use that billing data to find what's growing, what's becoming interesting. So then you identify new patterns because half the people build, I don't know, kit and internet, and a bunch of people build big data and they're growing. So you come out and say, oh, we should provide big data as a service. We'll give it a random name. We'll call it, I don't know, Elastic Map Reduce. And so what will happen is a whole bunch of people go, oh, well, they've eaten my business model. And a whole bunch of other people will cheer because now you've made it really easy for people to build new things. Okay, what's going on here? You're using everybody else as your free research and development department. They're actually doing the innovation for you. The bigger your ecosystem, the more innovation is going on. You're mining the metadata to spot future patterns, and what you're actually doing is commoditizing components. That's where you're focused on. And you simply move up the value chain on the right-hand side. Now, the point about this model is your apparent rate of innovation, your rate of customer focus, and your efficiency, which is economies of scale, now all increase with the size of the ecosystem. So the bigger your ecosystem, the more innovative, customer-focused, and efficient you see. Does that make sense? Anybody have a guess at a company who might be doing this? All right, literally you just literally build up on the right-hand side. I won't tell you this is a variation of a map that was written for a company back in 2018. There is a wonderful book called Reaching Cloud Velocity. It's the second ever book that AWS itself has produced. You'll find 17 pages of mapping in it, including that particular model as well. There is a player out there who's even better, and that's the Chinese government. They're really good at this stuff. All right, so X marks the spot. Let's summarize this all for you. 1, know your users. Oh God, I can't believe we still have to say that in 2024, but we do. Know your users, number 1. Number 2, know the details. You've had a lot of good talks today about things like value stream mapping. So these are all exposing ideas of understanding the underlying components. When we talk about a value stream is your organizational sort of sphere in a wider supply chain. And so it's really important to understand those components, and sometimes you have to go into, both up and down, the wider supply chain. So know the details. Thirdly, understand what is being considered. Compute as a product is not the same as compute as a utility, and it's completely different from, Line's electronic office back in the 1960s. So understand how evolved the component is. Once you've got a map, then you can start applying patterns. You can anticipate how things are going to change. Everything will evolve. We will have inertia. As things evolve, they will enable new practices. They will enable new higher order systems to appear. Those new things, you don't know what they will be, but you can keep an eye out for them, are where new sources of value will be created. Once you've got that, then you can start using that for investment, and most importantly, work out where not to invest. Don't invest in the stuff stuck behind inertia barriers, because all you'll do is build up those inertia barriers. It's about 16 different forms of inertia: political capital, physical capital, as in pre-existing assets. They're quite dangerous. Once you've done that, once you understand the space, how it's evolving, and you can have that conversation within a group, you can then start talking about, how do I manipulate this space to my favor? And that's X marks the spot. Thank you. I have a minute. Shall I tell you a horror story about AI then? All right. So there's loads of things I like about AI. I've been using them for many, many years in different forms, except for I don't like the particular term. But there are some issues. One of them is incredible biases within the system towards a market rather than societal needs. So be very, very careful of these systems if you do anything on government policy. They're quite dangerous. But what I want to talk about is to do, it's a bit abstract, but it's actually quite critically important. So if I look at 2018, and we talked about conversational programming environments, Alexander Simovich, how we got to basically became co-pilots. One of the interesting changes is the tool set is changing. So, we're moving from our typical coding environment to this sort of more conversational environment. The tool set is changing. But that also requires the language to change. So we're moving from declarative to much more conversational. Prompts are a programming language, Turing complete if they have memory. So we've got much more conversational languages. But another thing that's happening is the symbolic instructions are changing. So very much on the right-hand side, it's code as text. That's what we're used to, code as text. Now we're getting into a world where code can be things other than text. It could be images. And that changes the nature of the conversation. So this is a map of cohesive city transport with a whole bunch of transport planners around the world. We are looking at a bunch of issues. This is the code, and that's the image of the map. When we talk about the map, We're talking about objects, relationships, and context that exist within. That's the discussion that's going on. And it's through that we discovered virtual was a transport system that impacts other transport systems, and we've built all these digital twins which have basically ignored virtual. It's a bit like building a digital twin which has forgotten roads. I mean, it's a bit useless. On the left-hand side, the conversation's all about rules, syntax, and style. And you've experienced, who's an engineer? Right. You've experienced this. You have two different conversations when you're trying to solve a problem. One is on the screen, and that's all about rules, syntax, and style. And one is all on the whiteboard. You've all got whiteboards in your engineering departments where you all talk about the actual problem and you're actually talking about objects, context, and relationship. You're having the same conversation in two different formats. Okay. So what we've got is a change of tools, languages, and medium. Why does that matter? Those are the principal reasons, or the principal ways in which we reason about the world around us. So to give you an example, tool printing press, medium paper, language written word. Now imagine if somebody controlled that. I'm Charles Darwin. I've come up with this idea that species, over time, they change, they evolve. You say, oh, you can't have that word. We don't like that word. Oh, I think I'll write a paper on it then. Not on our paper, you won't. Oh, I think I'll publish it. Not with our presses, you won't. These are very powerful forces to have in the hands of a few people. So my warning to you is this. There's a whole bunch of people telling you that AI is dangerous and therefore you should trust them. You are creating a new theocracy if you do so. The only way to avoid this is to do the thing they don't want us to do, which is basically have it all open source. Of course, their lobbyists are out there telling you that if it is all open source, you'll get Skynet. So it's much safer if you trust them because they'll look after you. By open source, I do not mean just the code. I mean all the symbolic instructions, which includes all the training data as well. OSI has recently done a definition of where they've decided, for whatever reason, to first recognize that data is important, great, but they haven't recognized that the training data is in fact source. Okay? Now, if you turn up to an AI conference and say, this is going on, well, how will they respond? Burn him heretic. All right, thank you.